This wall has continuous insulation, yet moisture can still reach a cold surface. Why? Insulation, air control, and vapor control do not do the same job. Insulated wall. Still a moisture risk?
A wall may use one material for more than one function, or different materials for each. Thermal control slows heat flow. Air control limits unintended airflow. Vapor control resists water vapor diffusion. Heat flow is not airflow, is not vapor diffusion.
Insulation works most predictably when its thermal path is continuous. Interruptions can create colder local surfaces, but continuous insulation does not automatically seal air or vapor. Air control layers need continuity at joints, penetrations, and transitions. Air leakage can carry moisture much more quickly than vapor diffusion through an intact material. The exact risk depends on pressure, temperature, moisture conditions, and the complete assembly. Vapor control layers manage diffusion through the assembly. Their resistance depends on the exact material, thickness, coatings, and test conditions. A discontinuity may matter, but it must not be confused with an air leakage path. Diffusion is not air leakage. Some products may contribute to more than one control function. Others serve only one. Performance depends on the exact product, its installation, and whether the complete control plane remains continuous. Functions are assembly-specific. Instead of asking whether a wall has insulation or a vapor barrier, map each control function continuously around the enclosure. Then check every opening, connection, and penetration. Map the control layers. Every edge is a transition. Insulation, air control, and vapor control are related, but they are not interchangeable. A continuous layer helps only when it performs the required function in the complete wall. Continuous layers help, but complete wall performance is assembly-specific. Next node, foil-faced versus unfaced rigid foam. A thin facing can change vapor behavior. Vaporight Building Envelope Library. Educational information only, not project-specific design advice. Return to the failure case. The insulation is continuous and green, but a small unsealed penetration crosses the red air control plane. Red air enters the cavity. Cyan moisture reaches the cold surface. Insulation alone did not prevent this risk. Compare three transport mechanisms. Heat flow moves through solids. Airflow moves through gaps. Vapor diffusion moves through materials. Each mechanism needs its own control strategy. Zoom in to a rim joist detail. Insulation may be interrupted. Air control may be broken. Vapor behavior depends on the assembly. This is a conceptual detail, not a construction instruction. Window perimeter transitions matter. The air control layer must connect to the window frame. The thermal layer must wrap the opening. The vapor strategy must remain consistent. Every edge is a transition. Climate matters. Cold, mixed, and hot climates can shift where vapor risk appears. There is no universal vapor barrier location. The correct strategy depends on climate and assembly. Workmanship matters. A designed layer only works when it is installed continuously. Small gaps at seams, edges, and penetrations can undo the strategy. Details depend on the specific product. Liquid water is a separate concern. Rain and bulk water are managed by drainage planes and flashings. Do not confuse liquid water entry with vapor diffusion or air leakage. Ask 3 questions for each layer. Where is it? Is it continuous? Does it perform its required function? These questions guide the mapping, not a single universal answer. Continuity alone does not prove a wall is moisture safe or code compliant. Assembly design, materials, moisture loads, and applicable requirements all matter. This diagram does not replace project-specific assessment. Map thermal, air and vapor continuously. Check every joint, penetration, and transition. Confirm each layer performs its function. Then verify against the complete assembly context. Educational information only, not project-specific design, installation advice, moisture diagnosis, or code compliance guidance. Next node, foil-faced versus unfaced rigid foam.